You are currently the
Okay. Is it audible? Is it audible? So let us start. So we are going to start with the motion in 2D. So in this, right, so there are certain subparts. So one is the projectiles, and the second one is the circular motion. So now actually these are the two important motions actually we are going to deal in case of 2D. But actually the scope is not just limited to only these types of issues, but actually the combination of these things leads to motion and constrained motion. Motion under central forces. So all these things are actually the planar motions only, but actually we start with the fundamental discussions of the projectiles and we will extend to the circular motion, and these things are actually, there are separate topics that are dedicatedly on this. So but those are also as part of our 2D motion only. Right? So what it means for us is, as I explained earlier, so one dimensional motion is nothing but there is displacement only in one direction, or actually that is only one dimension is sufficient enough to describe the complete motion of the particle. Now in this case, suppose if a particle is taken in this way, then actually this can go in this direction or it can go in this direction, but it will always tries to stay in the same line. This is one dimensional motion. Now actually if you take the projectile we mean, suppose if I throw this chalk piece, then actually obviously there will be certain height at any instant of time and there will be certain displacement from my initial position. So these are the two different dimensions actually we have to be describing in case of two-dimensional motion. So projectile is one such kind of example where you have to be worrying about the displacement from the initial position and at the same time the height at any instant. These are the two important dimensions we have to be worrying. Now in this case actually, suppose this is the y direction, then a particle is thrown from here, then it will go in this manner and then it will finally drop to the ground. Now here at any instant if you notice, there will be a displacement from the position, let's say this is x, and at the same time there will be certain associated value of the height, so this is the y value. So at any instant these two dimensions actually we have to be calculating for the complete kinematical behavior of the particle which is traveling in two dimension. Now even in the circular motion also, if you can think of, so in a circular motion if you notice, the particle is traveling in this particular circular path. At any instant if you notice, there will be an x displacement and there will be a y displacement. The location is nothing but x comma y. So this is the circular movement, but still it is a planar movement. Even the planetary motion also, the Kepler's law, what it says is, that is the particle actually tries to move in an elliptical orbit. Here also ellipse is a two-dimensional shape. Now here at any instant if this is the location of the planet, then actually there will be an associated x value and there will be an associated y value. So this is the elliptical motion is also a form of two-dimensional motion. All these things are the subparts of our discussion, right? But in our syllabus, each one is a separate topic. So completely together, it will form as the dynamics complete topic of UPSC syllabus, right? So each one is separately described, but actually if you look at it, so this is very simple topic, dynamics completely. because actually one-dimensional motion and two-dimensional motion are only the two important aspects that are involved, not even 3D. So 3D are actually, we are going to deal 3D also, but not here in the vector calculus. Actually, we are going to deal as Serret and Frenet formulae, where actually the vectors will help us to solve the 3D problems very easily. Got it? So for this understanding of 2D, so at least for the projectile, we have to be knowing the parabola and its property. Because actually a two-dimensional motion, right? So is for a projectile, it will be a parabolic shape. Now actually we have to be knowing the properties of the parabolas so that we will be able to easily understand this projectile motion. Let me discuss briefly about the parabola, and then actually we will come back to our two-dimensional motion of projectiles today. Got it? Okay, now let us start. So we'll discuss parabola. So this parabola is nothing but, by definition, the locus of all the points which has a ratio of 1 for the distances from a fixed point and from a fixed line. Is called parabola. So this is the definition of the parabola. What it says is, there is a fixed line like this, and then there will be a fixed point like this. So this is one fixed point and this is one fixed line. And then the ratio of the distances, that is this is x-axis and this is y-axis, and this fixed line is called the directrix, and this fixed point is called as the focus. So this point is P and this point is S, and this point if I call as M, then SP by PM is equal to 1. So this is the condition for the parabola. The locus of all the points which maintains a constant ratio of 1 for this distance versus this distance. Now actually if I take one more point here, so this is the distance from P dash to S, and this is P dash to M dash. So SP dash by PM dash is again equal to 1. So if I take any point on this parabola, this condition is getting satisfied. So this is the rule of the parabola, right? Now this parabola has the properties of the focus, which we call as the fixed point, and this is the directrix, which we call as the fixed line. And so if you draw a straight line passing through the focus, which is perpendicular to the axis, so this is called the axis of the parabola. This is the axis of the parabola, and this perpendicular line drawn passing through the fixed point, which we call as the focus, and perpendicular to the axis, is called the latus rectum. Latus rectum. So these are the important aspects of the parabola. Now the equation of the parabola is, so for this parabola it is going to be y square is equal to 4ax. I will prove how it is. See this. This point, let us say I call this as x comma y as the point. And then this point, which is the origin, where I have taken as the origin, and this is the x-axis and this is the y-axis, and here it is 0 comma 0 is the center point, and this point is called as the vertex of the parabola. So if I consider this point, which is again on the same parabola, now SP by PM, so I call this location as Q, let us say, or O, this is O. Then as per the definition of the parabola, I call this as M1. So OM1 or SO divided by OM1 is again equal to 1, or SO equal to OM1. And then this length I call as the on the axis of the parabola. Let us say the focus is located at a distance of A, and from this understanding of A, we will try to calculate all other values. See this, if this is A, and based on this relation, SO equal to OM1 equal to A, because this length and this length are one and the same as per the definition of the parabola, being the parabola passes through the origin. So the vertex is located at the origin, which we call as the intersection of the parabola to the axis. And then from this relation, if it is A, then if I take a random point x comma y on the parabola, and this is the distance PM, which is equal to, PM is equal to this length plus this length. I call this length as, let us say, Q. Then PM equal to PQ plus QM. PQ plus QM. PQ is the x coordinate, because actually this is y axis and the length from the y axis to the x coordinate is nothing but the x. So this length is x, and this length anyway we know that from this relation this is again equal to A, because this length and this length are one and the same. So this is x plus A. This is PM, and SP, S is located at A comma 0, and then this location is x comma y. So SP is equal to, okay, first you note down this, I am going to erase it and write it. Done? This is just a quick revision. Don't take much time on this. So this is x plus A is PM, and SP is the distance from A comma 0 to x comma y. So this distance is SP equal to x minus A whole square plus y minus 0 whole square under root. Being SP equal to PM, SP square is also equal to PM square. So SP square is x minus A whole square plus y square is equal to x plus A whole square, or y square is equal to x plus A whole square minus x minus A whole square, and this value is 4ax. So this is the 4ax. And then here if you notice, this is the location where x is equal to A. The corresponding value of y from this relation is going to be at x equal to A, y square is equal to 4a into A is equal to 2a whole square. Then y equal to plus or minus 2a is the point where this value is A comma 2a and this value is A comma minus 2a, and the height is nothing but the length of the latus rectum. Length of the latus rectum is 4a. Got it? So this height and this height, the sum of these two will be the 4a. So in this equation, if you notice, x is at 0 comma 0 and the focus is at A comma 0. Length of the latus rectum is 4a, and the equation of the directrix is x equal to minus a or x plus a equal to 0 is the equation of the latus rectum, this latus rectum. So we have got the complete information about the parabola. I hope you understood this. Then we can go to our discussion. Understood? Any questions on this? Okay. So this parabola, so this is the right side parabola. Similarly, instead of x, if it is y, that is, if the parabola is upwards, then actually x square is equal to 4ay. This parabola is of the form like this. This is the parabola. And x square is equal to minus 4ay, and this is going to be the parabola in this particular format. So this is x square is equal to minus 4ay. This equation is y square is equal to 4ax. And the parabola towards this direction is y square is equal to minus 4ax. So this is the left side parabola. And then based on the shifting of the coordinate system, you can shift the parabola to any location. Let us say if you shift the parabola to a different location, let us say this is at h comma k, and this is the x-axis and this is the y-axis, and the parabola, if you draw in this particular format, let us say, and then these coordinates are h comma k, which is nothing but the vertex of the parabola, then the equation is going to be, it will fit to these forms, all the four forms, right? So here actually this is the downward parabola, which is this one. So x square is equal to minus 4ay is this equation. Now it is shifted to h comma k. If this is y-axis and this is x-axis, then the equation is x square is equal to minus 4ay. Now after shifting to this location of h comma k, then x minus h whole square is equal to minus 4a into y minus k. So this is after shifting the coordinate axis to a different location. Why I have explained this is, our projectile actually will form this parabola, right? So with this as the x-axis. So this is how actually the projectiles are projected. So if you start moving like this, then actually it will trace this path, the projectile. Got it? Now actually we'll go to our discussion. I hope you noted down this. Done? Okay. Okay. So in case of projectiles, right? So we tried analyzing the one-dimensional motion as part of rectilinear motion. There actually every particle is moving in a single line, maybe forward direction or maybe backward direction, maybe oscillating there itself, but it is on a single line. Now here actually in case of projectile, if you project from a fixed location, let us say this is x-axis and this is y-axis, and then the particle that is projected like this, it will come back and then finally fall at one location on the ground. Now here actually this path is going to be parabola, which is we are going to prove it now. See this. So here actually the particle is moving in a curved fashion, but we know the analysis of only one-dimensional motion. But here actually the particle is moving in a curved fashion in a plane, then actually we have to be worrying about two different directions. So this is one x direction and this is the y direction. So at any instant the particle actually is having both x coordinate and y coordinate, and the particle is moving along the x-axis and y-axis, so it will be having a velocity in the x direction and it will be having a velocity in the y direction also, and it will be having an acceleration in the x direction and it will be having an acceleration in the y direction as well. So what we are trying to do it here, it is because we know the rectilinear motion analysis, we will try to analyze with the help of rectilinear motion by dividing this motion, two-dimensional motion, into two different one-dimensional motion. That is, if the particle is projected like this, then actually I will call this velocity as u, and then in case of two-dimensional motion, you have to give the initial velocity of projection and you have to give the angle of projection with respect to the x-axis. So with the known values of alpha and u. In one dimensional motion, actually we are given only the initial velocity, no angle, because actually it's not required there. Here actually the angle is required, because actually this is being the two-dimensional motion. We have to be aware of with what direction it is moving with respect to the two coordinate axes. Hence, he has to mention the alpha value as well. Now, if I calculate the horizontal component of velocity, then it is going to be u cos alpha, and the vertical component of velocity will be u sin alpha. So, we came to the conclusion that we have projected the particle in certain direction with certain magnitude. Then that velocity I have divided into two different rectilinear motions. One is the horizontal rectilinear motion, which is thrown with a velocity of u cos alpha, and vertical component of the velocity which is thrown with a velocity of u sin alpha. Now actually I have divided the projectile velocity into two different one-dimensional motion, one with a velocity of u cos alpha and another with u sin alpha. Now both are actually associated with certain acceleration as well. Now this is a projectile, so the particle is always dragged towards the ground because of the attraction towards the ground, which we call as the acceleration due to gravity. So this acceleration, suppose if I leave this chalk piece, it automatically goes and falls down on the ground. How it got that velocity? Because of the acceleration that was given by the earth. So this acceleration is constant irrespective of the mass of the particle. Suppose if I take this chalk piece and if I take 1 ton of stone, then actually if I leave both, automatically these two will try to touch the ground at one instant. Though it is having maybe 1 ton or 1000 kgs and this is of only 100 grams. But still these two will fall down with the same time. This is the beauty of the particles falling, right? Now here actually this acceleration due to gravity will be given only for the particle traveling upwards, or actually the particle which is towards the ground or actually going away from the ground. This acceleration due to gravity will be associated. Suppose if I have to move this particle a little up, then I have to give a force which is equivalent to the mass and the product of the g. So mg is the weight of this particle, and that weight actually equivalently I should give it so that I can balance towards the attraction towards the ground, right? But in the horizontal direction, if you notice, except for the initial velocity whatever I have given, no other acceleration is acting. Because here actually no external force. As per the Newton's laws, one fundamental rule is, that is the first law. For every particle, right, every particle tries to stay in its state of rest or of uniform motion unless otherwise it is compelled by an external force. Now here actually in the horizontal direction no external force is there except for the initial velocity whatever I have given externally. And once it got certain velocity, no other force is influencing that. That means it keeps on moves. Even after falling here also it will try to move unless it is compensated by the earth friction. Once it falls down onto the ground, then actually there will be earth friction that will be coming into picture. Now that earth friction will try to stop. Otherwise it won't stop. It will keep on move. So if you move it on the smooth surface, automatically as there is no friction, it will keep on moves unless otherwise there is a friction position that comes in. So for vertical motion, rectilinear motion, there will be an acceleration of minus g. So this acceleration is minus g because it is trying to push down, though the velocity is going upwards. That means the acceleration due to gravity, which is the force towards the ground. And as I said earlier, force and acceleration are one and the same except for the scalar multiplication. That means this acceleration is nothing but the force that is dragging towards the ground. That is against to the velocity whatever I have given u sin alpha. Hence, the vertical motion is having an initial velocity of u sin alpha and is having an acceleration of minus g. But horizontal direction, I have given an initial velocity of u cos alpha and no acceleration is there. So this is no acceleration motion, horizontal. And here acceleration due to gravity. So this is actually dragging towards against the velocity. Hence, so the vertical motion needs to be considered as the motion under constant acceleration, the rectilinear motion under constant acceleration whose magnitude is minus g. But horizontal velocity actually we have to consider as the zero acceleration, where for zero acceleration we have only fundamental rule, that is velocity equal to displacement by time. So this is the only rule that is associated with the horizontal velocity. And the vertical velocity, we have different aspects. At any instant, the velocity is nothing but initial velocity u sin alpha plus at. Instead of a, it is minus gt. So at any instant, the vertical velocity is going to be changed with respect to time, but horizontal velocity is fixed and constant. So, and this value velocity is given as u cos alpha equal to x by t, or the x location of the particle is nothing but u cos alpha into t. So this is the x location of the particle at any instant, and the y location of the particle is going to be given by, so y is equal to ut plus half at square, where u is u sin alpha and minus half gt. So instead of a, I have put minus g t square. So this is the y location of the particle, and this is the x location of the particle, and this is the y location of the particle. Now actually I have got the information about the position at any instant in the form of the xy coordinates, whose x value is this and the y value is this. And the velocity at any instant, if you notice, and this is u cos alpha, the vertical velocity is going to be changed u sin alpha minus gt. At any instant, if I notice here, if I draw a tangent like this, this is the velocity direction, then there will be a horizontal component of the velocity given by u cos alpha, because no external force is changing this velocity, and the vertical velocity is nothing but this value. So at any instant, you have got the information of the velocity as well. You have got the information about the position in the form of x comma y. You have got the velocity in the form of u cos alpha and u sin alpha minus gt, and the acceleration anyway, horizontal acceleration 0 and the vertical acceleration is minus g. We have got all the information. Now, with what angle at any instant with respect to the horizontal, if it is traveling, if you ask, right? So this angle is the alpha direction. I call this as beta because alpha is already used. So if I calculate the beta, then tan beta equal to Vy by Vx. Because actually Vy is this component and Vx is this component, and this is the direction of the velocity. So Vy is nothing but u sin alpha minus gt divided by u cos alpha. So with this relation, actually you will be able to get the value of angle of direction at any instant for the particle, right? Now here actually the displacement, if you want to prove this as the projectile equation, now here two equations are there, u sin alpha into t minus half gt square and u cos alpha into t is the x location. Now here if you notice, x is expressed in terms of t and y is also expressed in terms of t, and this is actually we call as the parametric form of the equation. So in case of parametric form, the way we express is, we will try to introduce a new variable to express both the variables. For example, suppose if I want to say that actually father and mother relation, suppose if I wanted to express the father and mother relation, and then let us say I will call his son, and then actually I will show he is his father and she is his mother. If I say that, then actually everybody will get to know that both are actually wife and husband, and that relation indirectly I am communicating by introducing a new person, which is his son. So by introducing his son, you wanted to convey the relation between the wife and husband there. Same thing what we are doing it here. So here actually you wanted to express the relation of x and y, but here we have introduced a new variable t, which is in place of son in our relation. So t is the parameter. So this t is called as the parameter. Now if you want to straight away get the relation between x and y, eliminate parameter. Suppose actually if you straight away want to say that both are wife and husband, that itself is good enough to convey the same information. So whether you can express in the form of a parameter or if you express straight away relation, it won't make any difference for our mathematical analysis. So here actually x is equal to u cos alpha into t, I can express as t equal to x by u cos alpha. So this t value I have got. I wanted to eliminate this t by substituting in this. So y is equal to u sin alpha into t minus half gt square. And u sin alpha into t I can replace as x by cos alpha minus half g into x by u cos alpha whole square. So this way you can get the value y is equal to, so x tan alpha minus half gx square divided by u square cos square alpha. So this is the relation between x and y when you consider the projectile motion. And this relation, if you notice, so this is of the form y is equal to ax plus bx square format. So y is equal to ax plus bx square will always represent the parabola, right? In the form where the coordinate axes are shifted to h comma k. So that expression will always come in this particular format, because if you notice in our parabola equation, one side actually y and another side the square of the x will be there, and here also one side y is there and the square of the x is there, and this extra term which is coming here, and this will try to say that the x is deviated from the origin to some other location. That is what is the information that is it is going to communicate. Got it? So in this particular format, here tan alpha is in the place of a, and g by 2 u square cos square alpha in the place of b, and except that there is x and there is x square. Got it? So this way you are trying to get the relation between x and y, which we say that this is going to be a parabola. Got it? Understood how we brought the relation of the projectile? Any questions on this? Okay, so you can note down this. Done? Okay. So we have got the fundamental relation x is equal to u cos alpha into t and y is equal to u sin alpha into t minus half g t square, and then y is equal to x tan alpha minus gx square by 2u square cos square alpha. So these are the fundamental relations in case of projectile. Got it? So at any instant the velocity can be treated as v is equal to vx is equal to u cos alpha and vy is equal to u sin alpha minus gt. So this is the velocity relation. So we have got the complete kinematical behavior in case of a projectile motion. Now here actually if you want to find out some other informations like, see this, what is the maximum height it can travel, and this is the maximum height position where if you notice here, there will be a horizontal component of the velocity and the vertical component of velocity becomes 0 there. Because actually the vertical component of the velocity, it started with u sine alpha, it keeps on reduces based on the time depending upon this relation. As t keeps on increases and gt product increases and u sine alpha minus dt is going to be decreasing, and finally at one instant it will become 0, and that instant will be the vertical velocity of the particle becomes 0 at the highest point. Vy equal to u sine alpha minus gt equal to 0. It implies t is equal to u sine alpha by g. And this is the time at which the velocity, vertical component of the velocity will become 0. And this is if you take the horizontal direction as t and the vertical direction as v. Now here actually horizontally at this location, that is at a length of u sine alpha by g, and this is the time which we call as time of ascent. That means the time taken starting from here to reach the maximum point is called the time of ascent, and this is called as the time of descent, and the total time is taken as the time of flight. So, and this value of time of ascent is usually equal to time of descent in case of projectiles. Here, so time of flight actually we are going to calculate. See this. Time of flight. So if you take the y location of the particle is nothing but y equal to u sine alpha into t minus gt square by 2. And this y value is 0 at two different locations, these two locations. So this is equal to 0 where the particle started its flight and where it dropped onto the ground. And there actually, if y equal to 0, then obviously u sine alpha, I call this as the time of flight with a capital letter t minus gt square by 2 is equal to 0. Now this is, if you take t out from this, u sine alpha minus gt by 2 equal to 0. So two different possible solutions for this equation. One is t equal to 0, another is t equal to 2u sine alpha by g. So t equal to 0, the place actually where the flight started, and t equal to 2u sine alpha by g is the place actually where the particle got dropped onto the ground. Now if you notice, u sine alpha by g is time of ascent and 2u sine alpha by g is the total time of flight. Hence, if you subtract from here to here, then this is going to be time of descent. So this is the time of descent. And this value is again same value, 2u sine alpha by g, sorry, u sine alpha by g. And this is the time of descent. Got it? This is how you will be able to find out time of ascent and time of descent and the time of flight. And based on the time of flight, actually we are going to calculate the maximum range. Range is this length, starting from this location to the maximum distance it can travel. And this is the maximum height. So these two actually we are going to calculate it. You can note down this. So Krishna series is sufficient enough, Vishal. Okay. So we have got time of flight and we have got time of ascent. Now based on this information, you will be able to calculate the maximum height and the range. See this, maximum height is nothing but the time at which the time of ascent is complete. So at this location, the y coordinate is the maximum height. So at the end of time of ascent, the particle will reach maximum height. So y is equal to u sin alpha into t ascent minus half g into t ascent square. U sin alpha into t ascent is u sin alpha by g minus half g into u square sin square alpha by g square. So this g will cancel out, and then u square sin square alpha by g, u square sin square alpha by 2g, and the subtraction of this is u square sin square alpha by 2g. So this is H max. Got it? And similarly, the maximum range can be calculated, the horizontal distance for a time of type, so total time of flight. So horizontal distance is given by this equation. So x is equal to u cos alpha into t is the horizontal distance. So x at time of flight is the range. Got it? Okay, you can note down this, we are going to complete that. Done? So maximum range is u cos alpha into time of flight u cos alpha into time of flight is 2u sin alpha by g. Here 2 times, So this is u square sine 2 alpha by g. So this is the range. H max actually we have got u square sine square alpha by 2g. This is the H max. Got it? Now actually in this case, if you notice, for what value of alpha the H can be maximum we can throw. Here if you notice, when alpha equal to 90 degrees, so this can get a maximum value which is equal to u square by 2g. Now if you notice, if the particle is thrown like this chalk piece actually thrown upwards like this. Now actually this is again a one-dimensional motion, wherein I have given the velocity exactly in the straight motion like this. Now here, if I try to consider the one-dimensional motion is also as a projectile with an angle of alpha which is equal to 90 degrees, then this value is going to be 1, and u square by 2g is the maximum height traveled under the influence of gravity when we throw with a velocity of u, so which is the upward velocity like this. So this can be maximum and is equal to u square by 2g only that happens if I throw the particle with a angle of 90 degrees towards the horizontal direction. So from horizontal it is 90 degrees and we are throwing upwards like this. Now here u square sine 2 alpha by g, if I wanted to throw a longer distance, then actually the maximum longer distance I can do only with the help of the sine 2 alpha is equal to 1. So hence sine 2 alpha equal to 1 will give the maximum range. So this will give the maximum range where alpha equal to pi by 4. So if I wanted to throw maximum height, then actually I have to use 90 degrees. And if I have to throw longer distance, then actually I have to use the angle is equal to pi by 4. So these are the fundamental conditions that we can think of. Got it? And with time of ascent, the location of x will be x is equal to r by 2, which is equal to that maximum height at h max. And this value is going to be x is equal to r by 2 is given as u square sine 2 alpha by g. And if you notice, this is the point of the vertex for the parabola where that is located at u square sine 2 alpha by g as the x coordinate, and y coordinate is h max is given by u square sine square alpha by 2g. So this is 2g. So this is the point of the vertex of the parabola whose equation is given by this equation. Got it? The parabola equation also known and the vertex equation also known. Got it? So if you wanted to find out, okay, yeah. So if you want to find out all the aspects like actually the length of the lattice rectum or the focus point or the directrix equation, everything you can bring it out from this relation. So if at all those are asked, then actually you can use this relation. This is a simple parabola equation, nothing more than that. So the parabola equation needs to be expressed in this particular format of y square is equal to 4ax or x square is equal to 4ay format. Now in this case, I will give a general terminology what we are going to use. So this is equal to ax plus bx square is a parabola. Now here in this case actually this is in the negative direction, hence actually minus y is equal to ax plus bx square will be the downward parabola. With a comma b greater than 0. Then actually this is going to be the downward parabola. Now actually the standard methodology of converting this. So this is b, I will divide with b entire equation x square plus a by b times of x is equal to minus y by b. Now if at all an equation in this particular format x square plus a by b times of x, then this can be expressed as x plus h format like this. So x plus half of this value, that is a by 2b whole square minus of a by 2b whole square. So this equation is as equivalent as that of this one. These two are one and the same. So this methodology we are going to use in case if you wanted to express as x plus h whole square is equal to minus 4ay format. So this is the methodology which we are going to adapt for this equation if you want to express as a standard parabola format. Got it? So that is only simple mathematical analysis, nothing more than that. So this is simple parabola equation. That's what you need to think of. Got it? Any questions on this? Any questions on parabola or actually any questions on the projectile motion? So this projectile motion you need to understand clearly. Why? Because in case of constrained motion, these are the problems actually we are going to use there also in the constrained motion. Any questions on this? Okay. So I'll give you different methodologies. Suppose actually on the top of the building, some person actually throw a stone which is like this. Then actually in this case, what will be the angle alpha? So he tried throwing the particle like this in a horizontal fashion. So usually actually there were some questions like where the particle will be dropped or actually how far it is from this particular building where it was dropped. If he has given a horizontal velocity there. Now what will be the vertical component of the velocity and what will be the horizontal component of the velocity for this? And what will be the angle of projection? So a particle thrown from the top of the building which is dropped at a distance of x from the building. Now what will be the x? That is how actually the questions are going to be asked. Now here this one also will obey the rule of projectile, that is the projectile is a parabola. Even here also it will be a parabola or it will be a different one. Any answer? Okay. So here also it will be a parabola which obeys the same rule. Y is equal to x tan alpha minus gx square by 2u square cos square alpha, and it obeys the same equation. But here this is thrown horizontally with a velocity of u, then u sin alpha equal to u. That means, sorry, u cos alpha equal to u. That means cos alpha equal to 1. Cos alpha equal to 1, then alpha equal to 0. So he is throwing with an angle of 0. So angle of projection is 0 itself. You don't need to be worrying about it. In this equation, the angle of projection you can treat as 0. Then this is going to be 0. Then y is equal to minus gx square divided by 2u square. So this is the equation of the parabola where it is thrown from the top of the building which is in the horizontal direction. And there won't be vertical component of velocity because alpha being 0, u sin alpha equal to 0. So no vertical component of the velocity. But still it will try to fall down under the influence of the gravity, though you have given a 0 vertical velocity. That means if I drop the chalk piece, it won't stay here. It will keep on moves downwards because of the influence of the gravity. That's what is exactly happening here. You have given only the horizontal component of the velocity. That will be constant. Even when it falls onto the ground also, there will be a horizontal velocity. As I said earlier, we are trying to calculate the place where the particle got dropped onto the ground. But it won't stop there itself. It will move like this. It keeps on moves like this because of the horizontal component of the velocity, and that we don't consider for our analysis purpose. We try to consider the place where it got dropped just. So this is the place. and from this relation we have got the value of it. Now let us say the building height is h, then the h is nothing but this location, and where the x value is going to be h is equal to minus gx square divided by 2u square. Now here, this is where actually we take the coordinate system usually. As I said earlier, in the previous derivation of the parabola, where the x-axis and y-axis are started, there we have considered the angle of alpha. That means this is the x-axis and this is the y-axis and this is the origin. Then this value is going to be at a height of minus h, because this is the reference point now. So if this is the reference point, this is where actually we started the projectile with 0 angle and with an initial velocity of u in the horizontal direction. Then this value is going to be minus h, then this is going to be minus, and these two will cancel out, and then x square is equal to 2u square by g into h. So x value, you can take the root of it. Got it? So this value is nothing but the place actually where the particle travels a height of minus h and where it hits the ground, which is given by this relation. Got it? So whatever may be the kind of projection it is, the same formulas whatever we have used, these are the fundamental formulas which you can use at any instant based on your convenience, but appropriately you have to consider. The key point here it is, see this is where we projected, there you need to consider the origin. That is the fundamental rule. And the angle you have to consider only with respect to the x-axis. From the place we have considered the coordinate axis. These are the rules. The rest of the things are only just analysis depending upon the situation. Any questions on this? Any questions? Okay, so this is about the projectile motion. So maybe we will solve some problems based on this understanding. We don't take much of the problems in this particular case. Why? Because in constrained motion actually, we anyway have to solve all these projectiles there. There actually we consider more number of problems for the projectiles. Got it? We'll solve 1 or 2 problems based on this understanding, and then we will continue with the circular motion. Clear? Any questions on this? Okay, so that's all for today. Yeah, thank you. Good night.